All right, my friends, section 9.6 is called the polar coordinate system. And let's get started by talking about the polar plane and how to graph in a polar plane. To hand draw a polar plane, you can actually start just by drawing like an XY plane. Like so. And then, tick marks and all type deal. And then the difference between an XY plane though and a polar plane is instead of just tick marks, you'll have these radial lines. So here you'll draw a circle of radius 1. Hopefully you can do a better job in that third quadrant than I did. And then a radial line here to represent being 2 units away from previously known as the origin. We'll call it the pole. And then this would represent points with a radius of 3. And then you could probably maybe do one more. And, theoretically it could go forever. But I think 4 radial lines should be enough. There we go. Okay. In addition to having a component that tells you how far from the pole, so previously known as the origin, now known as the pole. We'll also have lines kind of to help you to know what angle of measure to use. This will remind you a lot of the unit circle. So previously known as the x-axis, this is called the polar axis. Also known as 0 degrees or 0 radians. This would be pi over 2, pi, 3 pi over 2. If you draw a line that goes, halfway through quadrants 1 and quadrants 3, that would be pi over 4. Splitting this into thirds, so you've got 15 degrees for each of those tick marks. Aiming at that second one there. You guessed it, that's pi over 6. Same thing over here. This would be pi over 3. Okay, labeling quadrant 2. Now, a hand-drawn polar plane could have lots of detail, like what we're putting on, or it could have not very much detail. So just you kind of put on the amount of detail that serves you for whatever problem you're doing. Since this is our first one, we'll probably just add in all all the unit circle friendly type stuff. Okay, and then let's just go ahead and label all the angle measures as they would have been on a unit circle. There we go. Okay, so now let's talk about plotting points in the polar coordinate system. An ordered pair in the polar coordinate system would always be of the form r theta. Where r, I'll say r is the directed radius. We'll talk a little bit more about the word directed there. And theta is considered the angle measure. Okay, so we'll do an example and then we'll try to make it more clear as to what I mean there. So example 1. Let's have you plot each point on the polar plane above. Let's have you plot point A with coordinates 2 and pi over 4. Go ahead and do that for yourself. Okay, I personally, when I plot these points, I always do the angle first and then the r value second. So for me, what I would do is I would imagine that you are standing on the pole, and initial position is that you're standing on the pole and you're facing 0 radians, which is so you're facing the this positive polar axis here. And then I would rotate the angle measure, so I would be facing pi over 4. And then if your r value is 2, that means you're going to go in the forward direction 2. So the point would end up being here. And hopefully that's what you were thinking as well. For point B, let's have you plot the point 3 and negative 2 pi over 3. Okay, again for this one, I would rotate the angle measure first. So just a couple comments here. Always standard position is standing on the pole and facing the polar axis. Since positive 2 pi over 3 is, 120 degrees in the counterclockwise direction, negative 2 pi over 3 would rotate you and you'd be facing 4 pi over 3. Your r value being positive 3 means you're going to go toward that direction 3 units. So point B would be there. All right, point C, negative 1 and pi over 2. Go ahead and see where you'd put that. Okay, again, I always do angles first, so I would stand on the pole facing 0, rotate pi over 2 radians, but this time your r value being negative 1 means instead of going toward the angle 1, you're going to go away from it 1, which is what is meant by directed radius. So point C would land there. Okay. A lot of folks at this point start noticing that unlike in the rectangular coordinate system, a point in the polar system can have many different addresses that would get you to the exact same location. So let's investigate that a little bit here in example 2. So example 2, let's have you find 4 different coordinate pairs for each point in example 1, from example 1. Okay. And you know what? Let's change the directions just a little bit. Let's not do each point. Let's pick a point. So let's say point A. For point A from example 1. How about that? Okay, so let's look at that. Point A, was given as 2 pi over 4 here. But let's think, are there some other ways that you could get to the exact same location? So some folks might notice you could do 2, and then you could make, kind of do an extra rotation around the circle. So that would be 2 pi plus pi over 4, which if you clean that up, you get 2 and then I think 9 pi over 4. There we go. So there's a different coordinate pair that would get you to the exact same location. Let's see, what else could we do? Let's play around with maybe a negative r value. So let's say we want to use an r value of -2. What angle would make sense there? So you could use, let's see, 5 pi over 4 and then -2. There we go. So there's another one. We could do, let's try a double negative. Let's see, -2 for the r value, and then let's do, what would 5 pi over 4 be if you were to express it as a negative angle measure? So it would be -3 pi over 4. There we go. So you've got -3 pi over 4 and then -2. Okay. Let's see, let's come up with another one. How about let's go back to a positive r value, and then let's see, what could we do? Positive r value and then maybe a negative angle measure or something. So +2, and then let's see, you'd have to rotate, whoopsie, that was kind of funny. You'd rotate, there we go, from 0 and then back around. So that would be -7 pi over 4. There we go. So there's 4 different ways to get to the exact same point. Last example for this part of the video. What if I asked you to list all possible ordered pairs for point A from example 1? So think about it. What if I wanted you to list all of them? How could you do it? Okay, so notice that really if you look at the answers that we've got so far, you kind of have 2 ways this could go down. You could have a positive r value, or you could have a negative r value. So let's look at, what if you have a positive r value of 2? So if you have a positive r value of 2, then you'd look at all the different ways to describe something that would land you at this angle measure right here at pi over 4. So how could you get to that exact same spot? Well, you could have pi over 4, or you could go all the way around any number of times, either positive or negative. So you could have 2 and then pi over 4 plus 2 pi n. There you go. Now let's talk about the ways to get to that same spot using a negative r value. So you could have negative 2, and then you'd want to basically, so negative 2 you'd need to get to this, essentially this location here for the angle. So you could go back to get to point A. So that would be, you could write 5 pi over 4 plus 2 pi n, just to get back to 5 pi over 4. So 5 pi over 4 plus 2 pi n. And then we would say for all n values from what set of numbers, so that you would have exactly 1, 2, 3, 0, negative 1, negative 2, negative 3, etc. put in. Yeah, the integers. There you go. All right, my friends, that's the first video of section 9.6. Hope it helps.